Welcome back to Operating Systems Crashcast. I'm Victor, and today we're diving into Section 5.10, Alternative Approaches to Process Synchronization. Sheila, are you ready to explore some cutting-edge solutions?
Absolutely, Victor. It's fascinating to see how the field of operating systems continues to evolve. Let's start with transactional memory. Can you give our listeners a brief overview?
Certainly. Transactional memory is an alternative to traditional lock-based synchronization. It allows programmers to define sections of code as transactions that can be executed as a single unit. Think of it like database transactions. Either all the operations in a transaction complete successfully, or none of them do.
That's an interesting analogy. So, how does this help with synchronization issues?
Great question. Transactional memory simplifies concurrent programming by eliminating the need for explicit locks. The system automatically manages conflicts between transactions. It either allows them to proceed in parallel or rolls back and retries if conflicts occur. This can lead to better performance and fewer bugs compared to manual lock management.
I can see how that would be beneficial. Are there any drawbacks to using transactional memory?
While transactional memory is powerful, it does have some limitations. It can add extra work for short, simple operations. It may not suit all types of concurrent algorithms. Also, hardware support for transactional memory is still evolving, which can affect its performance and adoption.
Interesting. Let's move on to another alternative approach. OpenMP. Can you explain what that is?
Certainly. OpenMP stands for Open Multiprocessing. It's a tool that helps programmers write parallel programs more easily. It works with popular programming languages like C, C++, and Fortran. OpenMP provides a set of instructions that make it simpler to create programs that can do many things at once.
That sounds useful. How does OpenMP handle synchronization?
OpenMP includes built-in tools for synchronization. These include critical sections, atomic operations, and barriers. These allow programmers to specify which parts of their code can run in parallel. The OpenMP system then takes care of creating and synchronizing the separate threads of execution.
I see. So it's a higher-level approach compared to manual thread management and locking. What are some advantages of using OpenMP?
The main advantages of OpenMP are its simplicity and portability. It allows developers to gradually make existing sequential code run in parallel, often with minimal changes. OpenMP also works well on systems with multiple processors sharing memory. It can significantly speed up certain types of applications.
That's impressive. Now let's talk about the last alternative approach, functional programming languages. How do they relate to synchronization?
Great transition, Sheila. Functional programming languages like Haskell or Erlang take a completely different approach to concurrency. They emphasize data that doesn't change and functions that don't have side effects. This naturally eliminates many synchronization issues. In these languages, shared changeable data, the root cause of many synchronization problems, is either discouraged or not allowed at all.
That's a fascinating approach. Can you give an example of how this works in practice?
Sure. Let's look at Erlang, for instance. In Erlang, each concurrent task runs in its own isolated process with its own memory. These processes communicate by passing messages rather than sharing memory. This model, known as the actor model, eliminates the need for locks and other low-level synchronization tools.
It sounds like functional programming languages offer a very different way of dealing with concurrency. To wrap up, could you summarize the key points of these alternative approaches?
Absolutely. We've covered three main alternative approaches to traditional lock-based synchronization. First, transactional memory, which allows code blocks to run as a single unit. Second, OpenMP, which offers high-level tools for parallel programming. And third, functional programming languages, which use unchangeable data and message passing to avoid synchronization issues. Each of these approaches has its strengths and can be particularly useful in different scenarios.
Thank you, Victor. This has been a fascinating exploration of alternative synchronization approaches. To our listeners, we hope you found this episode informative. Join us next time as we continue our journey through operating systems concepts. Until then, happy coding.